In this video, we are going to be taking a look at an AC coupled system that combines microinverters, a 20 kilowatt Deye Hybrid inverter, and a high voltage lithium ion battery bank. This is an AC coupled system, and we've got about 15 kilowatts of solar connected to the inverter on the gen input. So what we'll see on this screen over here is that the solar shows 0. So we see 0 solar there, but we do see the microinverter signal over there. We can see at the moment only 1.38 kilowatts coming in. That's because it's a bit of an overcast day. So if we step back, let's just take a look at the system. We've got 30 kilowatt hours of battery storage over there. We've got a 20 kilowatt inverter, and that board over there is our micro inverter combiner box. Now, if we take a look inside, what we'll see on the inside, let's just take a look at the cabling. So we've got the micros to gen input is the cable on the right hand side, and that's microinverters feeding to the inverter over there. The cable on the left hand side shows from solar AC microinverters 25 amp max. So that cable over there goes all the way to the top. It goes through the roof. So we've got our microinverter line coming down, going into this board, and then behind there it goes into the trunking. It goes up the trunking, around through the surge protection, through the Q relay, goes out through the 4-pole isolator, onto that cable, and runs through. Cool. If we take the cover off and we look at the labeling at the bottom over here, we'll see AC supply to inverter. That's the cable sitting over there. This AC supply comes all the way from that board. Then over here we've got the micros to gen input. So this is the cable coming from that board, comes all the way in, connected to the front. If you have a look at the labels, it shows right there, it shows gen neutral, gen line 1, gen line 2, gen line 3. And then the load for the inverter sits on the cables all the way towards the back. This particular inverter is operating way below its capacity. You'll see that at the moment it's only drawing 1.8 kilowatts. So at the moment the system is functioning quite well, working on an AC coupled system using Enphase iQ8 micro inverters. What it looks like inside this cabinet, this cabinet, or the intention of the cabinet was to have something that is air conditioned. It has smoke alarms, fire alarms, all the bells and whistles. And over here we've got the 30 kilowatt hours of battery storage. The batteries that we've connected over here are high voltage batteries. We've got quite a few cables coming out. What we've done is we've separated the positive and negative cables. We've done them in steel conduit, because this is a commercial industrial environment. We wanted to try and keep everything industrial. He even went as far as using those stainless steel saddles. I personally think it's a bit of an overkill, so we just did a couple of those because the cable that we're using over here is only 16 millimeter 4-core cable. Even the cable is a bit oversized, but that's the cable we had in stock, so we decided to use it in any case. One of the issues was that the supply for the Enphase controller is supposed to have the same phase sequence as the site. And this particular site phase sequence is in reverse, so we had to swap out the red and yellow because the red and yellow is swapped throughout the entire site. Other issue we had was on the CTs. The CTs are obviously directional, and you can see the little arrow over there. So the CTs were pointing in the wrong direction. What that did on the monitoring of the system was it actually halved all the production from the micro inverters. So what we saw, the micro inverters were busy producing, we only saw half of those values on the actual Enlighten app. Something that you might want to just look out for is when you work with these CTs have little clips. And those clips are extremely sensitive, or maybe I should call them brittle. We've broken off quite a few of them on some of the installations. And when those clips break, the only real solution we found that's an easy and a quick fix is using a cable tie just to keep the CT clamped together. That seems to do the job. I did find interesting about this particular installation was that these inverters, that's a 20 kilowatt inverter, but on the high voltage cables going into the inverter, it can only handle a 6 millimeter square cable. So on the high voltage batteries, so on a high voltage battery, you've got a 25 millimeter cable connecting the stack together. So you've got a 25 mil cable running out, and in the inverter you've only got a 6 mil cable termination point inside the inverter. So you've got to have an area where you would be able to terminate the 25 and go from 25 through to 6. So you've just got to ensure that your breaker size over here is the right breaker size and voltage rating size for the type of cable that you're going to be using. One of the other things you've got to make provision for is just the number of cables and cables you're going to have that's going to come out of your unit. So what we've got here is the supply going into the cabinet for the air conditioner. We've got the green cable, obviously for bonding purposes. We've got the comms cable going from the high voltage batteries to the inverter, and then obviously the positive and the negative. So it's important just to make sure that you've got that covered, because that's quite a bit of cable work that you need to make. It's fairly obvious that your cable rack. At the time of making this video, we still had to do the labeling. We've done the danger signs on the doors, but we are still in the process of just finalizing and completing the labeling for this particular installation. So with the labeling completed, we have the microinverter control board. It says fed from microinverters and the sub DB warehouse office. That was the first DB we just had a look at. On the inverter, we said fed from microinverter control board, sub DB warehouse office, and high voltage battery cabinet. And then on the battery cabinet, we've got high voltage battery cabinet. So all of the equipment we've installed has been labeled, and it should be fairly easy for anyone who gets to this installation to navigate and find their way around the system configuration and how the different components relate to one another. If we have a look inside this one, we have now added stickers there, some labels there, from micros, just to indicate the direction of flow. Relays, and right at the top we've added some labels to those guys. Okay guys, thanks for watching. That's the end of this episode.